Okay, awesome. All right, well, welcome to GroupBy, everybody. I'm not used to doing this particular presentation virtually, so this is normally a pretty interactive session. So with Erin as my moderator, feel free to stop us for questions at any point in time. Share your stories. I don't know if you're able to unmute your mic or anything like that, if anybody has that ability to jump in with questions, but we'll leave that to Erin. Erin, definitely interrupt me at any point in time. Just to let everybody know, it is a 100, 200 level session without demos. I do this purposely to give you guys an opportunity to make a checklist, to go back to your systems and double check using my slides, each thing that I go over to see if you have your system set up correctly or if there's any modifications that you can do to your system to improve performance. So just to kind of lay that out for everybody, that's the plan. I can do this session in 50 minutes. I can do this session in 90 minutes. So we shall see how this goes, depending on the questions that happen. We could have a little free time where Erin and I can sit and chat for a while after this, or we could be pushing it until the next speaker starts. So let's see how it goes. This is Performance Tuning, Big Bang for Your Buck. I'm Monica Rathburn. I work for Denny Cherry and Associates Consulting. So if I come into your system, these are the type of things that I'm going to be looking at as a beginner's checklist to see if you've got things properly configured and different things we can give you the biggest bang for your buck to get in there and get performance going. This is a little bit about my information here. You can always reach me at SQL Espresso on Twitter. I blog weekly, not so much since we've been in quarantine because I've been so busy at home with everything else, but I'm working on it. You can find those at SQLEspresso.com. I'm obviously very active in the community. You can see with all the environments and all the badges I have at the bottom, and I'm a Microsoft MVP. See if this advances. This is going to be fun. Let's see. Did it pop up? We're going to go forward once we work out this kinks. Okay, so this is my presentation rules, and this is where it's going to get really interesting now that we're virtual. I love, love, love questions. I love to be interrupted and have a two-way conversation. I think it's so important with sessions like this that you guys get out of it what you need to go back and improve your environment. And if it's just a matter of me lecturing at you, sometimes that doesn't necessarily work. So if we were doing this in person, I'd be asking questions to you as well as you was asking questions to me. But since this is virtual, we'll see how we do. And we'll take it from there. Looks like my clicker is not going to like this environment. Okay, so we're going to talk about first best practices. This is going to be everything you need to do inside and outside SQL Server to gain some performance. They're quick and easy things. Some of it is a lot of common sense. Some of it is, oh, I didn't take it one step further. And conversations you might need to have with people outside of the database realm to improve performance on here. So let's get started and take a look. Might be actually using my mouse instead of my clicker. Okay, so first thing is not having anything to do with your SQL Server. It's the box that you're on. It's your power plan. Think of your power plan as making sure your car's engine is ready and revved and ready to go as soon as you hit that gas. With a power plan on a box, usually the default is set to balanced, which means your server is in a let's say you're just idling and then it revs up and takes off and then it idles again and revs up and takes off. You can imagine for SQL Server what that can do to the CPU and what extra overhead that creates. If you put it in high performance, it will actually keep your engine revved, it's ready to go, you don't waste CPU cycles, and you're able to take advantage of that CPU power. So what do? It's just a Windows setting. It's a power option in your control panel. It's just set that to high performance and it will actually make a huge difference for you. Also, if you think outside of SQL Server and outside of the box that you're on, if you're in a virtual environment, have you ever thought to ask your admin if your host is on high performance plan? The actual host can affect your performance, as we all know. So these are questions that you should actually ask them. Write it down. Sure you take this back to them. One big thing that a lot of people don't know is that if you are unbalanced, you are only using 70% of your CPU's power. That's a 30% degradation on your box right out of the gate from this simple radio button that can be switched. So definitely take advantage of that, switch it, gain that 30% back, and you'll actually see a difference. You can actually use what's called CPU-Z. I don't have it on my slide. It's a download software you can download, and you can run it, and it will actually show your benchmarks before and after you turn this on. It's a huge difference. Take my word for it. Double check the boxes that you're on right now. Make sure they're on high performance. If they're not, and it's out of your control to make this change, definitely talk to an admin that can make that change for you and apply it to all of your boxes. Okay, services. This one cracks me up. How many people actually come onto a box when they first go into an environment, go and check the SQL services, and look and see that whoever installed SQL on that box installed everything? Aaron, I'm sure you have. You've walked into a system and actually seen everybody checked every box upon the install, and you end up with analysis services, you end up with SSIS, you have your engine running with reporting services, which means all of these services are actually trying to compete and use the same resources. What does that do to your engine? It takes power away from it. It actually causes a performance hit for you. So I really want you to go back into your system, take a look and see what's installed. If you're not using analysis services, turn it off, disable it. If you're not using reporting services, turn it off, disable it. SSIS is the biggest one that you'll see. Actually, you guys see, we're actually working from home. We have a little visitor who's come and decided to take over my thing. So let me see if I can get her out of the way. All right.
As you predicted.
All right. SSIS is one where many people actually install it on the box. They have every intention of using it when they first set things up. But as they get going with the machine, they decide they're not actually using SSIS. They've used something else to do their ETL, yet they still have integration services running. I want you to make sure that when you go back to your systems, you turn off any services you don't need, including SSIS, and we'll talk about some reasons why as we move forward. But double check, why are you using it? And if you are using it, is it possible to put those services on another box? Can you install SSIS on their own VM? There's reasons to do that. It is another license that you have to have. So sometimes it's cost effective not to do that. But the goal is to have your engine running by itself. You should only see your engine, agent, and the other required services to run the engine running. Take off SSIS, take off SSAS, and reporting services, and set them up on their own box if you're able to do so. Okay, patching. Everybody cares about patching when it comes to Windows.
Hey, hang on. I'm gonna interrupt you for 1 sec. Hang on. Can you do me a favor? Totally switching context for a second. There's an issue with your video, so we just want to try something. Can you turn your camera off for a second and then flip it back on and see if that helps? So stop sharing video, bottom left, right? Yeah, perfect. Okay, so now I just see your name. That's great. Now bring it back in.
Let's see. We good?
It's still lagging a little bit, but I think
I can turn the video off. That's not a problem. What matters is on the screen. So let's do that.
That's true. Okay. And I'll turn mine off as well. All right.
Let me go back a slide. Okay, are we good now?
Yep.
All right. So do I need to back up at all, Aaron, or are we good?
What are you on? You're on patching. Perfect.
Yeah. Okay,
yep.
Great. All right. So patching. I hear everybody talking about security issues and how important Windows patches are. And I've heard the arguments of, you know, your admins installing patches without letting you know and rebooting your box and things like that. So everybody's focus seems to always be on the Windows patches. However, I find a lot of the times that it's the SQL Server patches that can make a difference for performance. Why? It's the bug fixes. A lot of the patches that happen inside SQL Server is to fix issues with pieces of SQL Server itself. So if you are not maintaining the latest patches, or you are near the latest patches, you are actually having performance degradation that you might not be aware of. For example, with SQL Server 2016, when that came out, there was some issues with the optimizer that got improvements with SP1. If you currently look at your environment and you are on 2016, but you are not at SP1, you are running with performance issues that you probably aren't aware of. So it's definitely something that you need to think differently about. It's not just about security, which is important. It's also about those bug fixes. Again, you know, a lot of things are out of Microsoft support. If you're sitting on SQL 2008 R2 and you have a major issue and you don't have an enterprise agreement or an SA agreement with Microsoft, you're out of support. You need to be able to pick up that phone to Microsoft and ask questions to fix your environments. And if you're not on the right path, you don't have the ability to do that. Again, outside of SQL Server, remember, everything that happens with the hardware associated with your SQL Server affects your performance. Drivers on your VMs need to stay up to date. Your NIC cards, there are patches just like within SQL Server that fixes bugs or it makes improvements to those pieces of your environment that can make a huge difference inside SQL Server. So ask the questions, talk to your admins. When was the last time the drivers on these VMs were updated? When was the last time vSphere or VMware was updated? Your NIC cards, double check those things and make sure you're staying on the best, the most recent that you're able to go to. Again, Windows patches, we all know to stay on top of those, but start to think outside of your SQL Server with upgrades as well, making sure all your complete environment is patched. Memory, this is a good one. How many of you guys have actually come into a system where the max memory setting is set on 2.14, blah, blah, blah. That means your memory has never actually been performance tuned. And this is something you need to go back and look at. Setting your min and max memory can make a huge difference, because what this does is tell SQL Server how much memory it's allowed to use. And it will actually build and build its memory until it hits that max memory. And then it won't take any more, leaving the rest of the memory to the OS. If you do not change this value, it's possible that SQL Server can starve your OS of memory, and you could run into some issues, some memory exhaustions, things like that. So it's important to set that max memory and reserve the memory for SQL Server. There's a lot of people that actually say your minimum memory, maybe you need to set this, maybe you don't. To me, it's not as big of a concern as the max memory, but I do want you to take it into consideration. Setting this value to something that gives SQL Server enough memory to start is good. Sometimes it's as little as 4 gigs, sometimes it's 12 gigs. However, whatever you do, do not set it to the max memory that is sitting on your box. Making sure that your max memory and your min memory doesn't match is probably a good thing. You definitely don't want to set those values exactly the same, and I've seen that before. Multiple instances. I know a bunch of people who have multiple instances on a box, and I've actually gone and you had them use, do you know Jonathan Cahias? He works with Aaron at SQL Skills. He has a really great script that kind of gives you the magic number of what to put in that max memory. There's a big calculation for it. He's done all that for you. If you run his script, it will give you the exact value you should have in this max memory. And I've actually had people use that script, put the perfect value in there, which was fantastic. But then they had multiple instances on the same server. So what did they do? They ran that script again, and they put that exact value in the max memory. So for example, I have 64 gigs on my box. I run this, and let's say Jonathan's script tells me I need to have 52 gigs sitting here. So I put in 52 gigs as my max memory value. I go over to my other instance, I run the query, and again, it tells me 52 gigs. I put 52 gigs in there. What did I just do? I put 104 gigs on a box that only has 64 gigs of memory available. So I completely screw up the box. I don't, but I've seen users completely screw up the box by over allocating the memory when it comes to multiple instances. So I want you to make sure if you're running multiple instances on your box that you are allocating just the amount of memory spread throughout the multiple instances. Don't over allocate. I've seen this way too often. It doesn't mean you have to put the same value on both instances. Maybe one of the instances only needs 12 gigs and the other instance actually needs 32 gigs. And then the rest is left for the OS. So definitely make sure you have that setting spread across properly with each of your environments and knowing what instance requires what. Okay, so let's talk about extra services. Remember earlier I showed you how some people install SSIS, SSAS, SSAS, IS on the same box. Now I want you to note that that max memory setting right there is for the engine only. The extra services use the OS memory. So if I'm actually running SSIS on this box and I've got my max memory set to, I don't know, I use the old fashioned rule where I say I leave 4 gigs for the OS and the rest go to max memory. And then I have SSIS running. That means I'm actually sharing those 4 gigs that I left for the OS with those additional services, which means when my SSIS packages run in the morning, they're taking forever to run because they're sharing the memory with the OS. Or I'm seeing memory exhaustion errors on here, and I know I have my max memory set correctly. These are the things that you have to look at outside of what your SQL Server max memory is set. You need to know what services are running on the box. Now there's also locked pages in memory. I'm not going to go into that. I want you to research that and see if it's right for your environment. There's some caveats to that, but I want to make sure that's something in your brain when you think about memory. When we're talking about SQL Server, like I said earlier, I want you to think outside of just the engine. I want you to think of the hardware that it's on, especially if you're in a virtual environment. Have you asked your VM admins to set your memory reservation on the host? There's a thing called a balloon driver inside VMware, for example. And what it does is it actually allocates memory and parses out the memory with all the VMs on the host. If one host needs more memory for something, it can actually moderate that memory and give more to one host versus another. And its job is to make sure everyone has the right amount of memory it needs to run. And it can actually steal memory from your host, from your VM. So if you have your admin set your SQL Server memory as reserved for your particular VM that houses SQL Server, then that balloon driver cannot touch that memory. So I want you to go back, not only ask if your power setting is correct, but I want you to go back to your admins and I want you to say, hey, can you reserve my memory for this SQL Server VM? That way the balloon driver can't touch it. And remember, don't over allocate. That means on the host as well. Make sure whoever's maintaining that host is not over allocating the memory on that box. In that case, if that happens, that balloon driver starts to work really hard. And if your memory reservation is not set, you have an issue.
Okay, I'm gonna hop in. Yep, perfect timing. So there's a couple questions. There was one which was, what's the optimal memory to set, max server memory to set for a server that has 16 gigs? And you had mentioned Jonathan's calculation, right? Which he has a blog post for that. So I didn't do the math on that number really quick, but I dropped the blog post into the chat, and I'll also put it in as an answer. So his post just talks about how much you need to reserve based on how much memory is on the box. The second question was, isn't it also not recommended to install Management Studio on the server as well, because it can consume memory if left open? So there are lots of best practices when it comes to having your server optimal. If you're able to not install Management Studio or any other components on the box that houses your engine, I highly recommend it. However, there are instances where someone needs to be able to get on that box and work. They may not have a jump box, or they may not have a client box that they can use to run Management Studio. And therefore, I'm a little forgiving on that. And as a consultant, sometimes I need to be able to get directly to the server and work because I can't use Management Studio locally, or they don't give me a jump box, and I don't have a choice. Best practice would be don't install it. Logical everyday use, sometimes you have to go beyond that, and I'll forgive you. Okay. And then I'm going to go back to, somebody mentioned that there is a DBA tools PowerShell command that will test and give recommendations on max memory. I'll admit that I haven't tested that, Monica. I don't know, have you done that?
I have not tested that, but I am a huge fan of DBA tools, and I'm sure they've got that piece covered, and I'm sure it's reliable.
Right. Oh, it uses Jonathan's script. How clever. It's all integrated. And then one last question for this section, which is related to SSIS, and I am not an SSIS guru. So if you're using SSIS packages, do you need the SSIS service?
So I believe when you say you install SSIS on another server, I think you can point where you want the SSIS DB to be stored, and it could be put on another server, but I am not an SSIS guru and I haven't had to touch that in a little while. So I cannot give you a straight answer on that.
Right.
Sorry.
And I think, no, that's okay, because I also pinged John just to see, just meaning John, your coworker. There's some version things that we were discussing, as well as whether you have your packages in MSDB or whether you have them in a file system. So not 100% certain. I need like Tim Mitchell or Andy Leonard to hop in.
Right,
on that
Andy
one.
Leonard is a great resource for that, for sure.
Right.
He probably has something on it, or you can hit him up on Twitter. I'm sure he can answer that question for you.
Right. Okay, we are caught up.
Okay. All right, so TempDB. I have an entire 90-minute session on TempDB, but since that we are condensing this into 60 minutes, I'm going to hit the high points, and I want to make sure these are the items that you take care of. And it's so important that many of these have been defaulted as you go to 2019, and some of these in 2016. And your initial setup, if you're clicking through the wizard to install SQL Server, they're starting to implement some of these things as part of the setup to make sure they're being done in environments. So that's what we're going to talk about here when it comes to TempDB. We're not going to dive a ton into it because, like I said, I can talk forever on what to do with TempDB, but we'll touch a little bit. The first thing is making sure when you are setting up your server, you are talking to your admin about disks. When they're setting up your SAN, or they're giving you whatever disk space that you're going to get, talk about making sure TempDB is on its own. Talk about making sure it's on a high performance disk. You really want the biggest throughput possible when it comes to TempDB. Why? Because everything in SQL Server uses TempDB. You've got sorts, you've got a lot of version stores that happen. You have a lot of your temp tables, your table variables. All of this stuff uses inside TempDB, as well as a lot of things behind the scenes inside SQL Server. So it's critical that you as an admin set this up correctly to make sure you're getting the highest performance possible, including talking to your admin about disk. Multiple files. This is just a standard setup here. If you have one file per CPU core, that's what you want to do at a minimum. Now you'll see where I'm saying multiple files, but up to 8. There is a rate of return that happens. And sometimes you can create bigger performance issues by having too many TempDB files. So definitely take a look. There are edge cases where you're going to need more files, but that's knowing your environment and having a little more knowledge about what TempDB does. But for the most part, in most environments, you can go with the steadfast rule, 1 file per CPU core up to 8. Now note what I have in the squares here, your auto growth and your initial size. These are critical. You want to make sure each one of these are set exactly the same. All of your TempDB files should be, your data files should be the same size. Why? I bet you if you go into your environment right now, and this isn't something that you've taken into account, you probably have that first file, I'm just guessing, maybe that says 25 gigs. And then your TempDB 2, 3, and 4 are sitting there at 10 gigs. Well, if the first one's set at 25 gigs, that means everything that comes inside TempDB, they're all vying, all transactions are vying for space. So where are they going to go? They're going to go to the actual file with the most space, right? So everything right now is actually in your first TempDB file. And then you end up with this thing called contention, everybody vying for that space. And that one ends up growing and the other ones don't grow and they stay the same size. And then you get this whole contention thing that happens. Now, this is a whole complicated story that I can explain of how the pages work and all that kind of stuff, but we're not going into that. In general, I just want you to take a look. I want you to look and see that they're all sized the same and you don't have any one bigger than the other. By doing that, you're creating contention. So I want you to go into your TempDB. I want you to set the auto growth exactly the same for each one of them. And I want you to set the size for each one of them exactly the same.
Okay, so
yes.
A couple questions.
Yes.
What is a good size for each TempDB file? Do you have any recommendations?
There's the lovely question of, it depends, right? All depends on your environment. So if I don't know my workload and I'm averaging, you know, I'm kind of just guessing it's a normal workload. Maybe I set each one of these to 10 gigs. There's 40 gigs right there. If you can set each one of them to 25 gigs, maybe you set each one to 25 gigs and you have a total of 100 gigs that you've given to TempDB. There's ways that you can trace this. You can see what uses TempDB. There's queries you can run to get a better value. It's hard to say, you know, setting these at maybe a gig a piece could be fine for your environment if you don't have a lot of throughput. So it's hard to say. Coming into the environment, you really have to know what your data looks like, what your workload is gonna be.
Right. Sometimes I let it run.
What's your go-to default?
So here's the thing, like I don't want to have to shrink them back down, right? Like I want to set them and be good. So they start out really small. Sometimes I let that workload run, come back in after what's a quote unquote normal time period or representative time period, check to see what the sizes are and then size them according to that. So if they've, you know, they could be different sizes, but if they've all grown to something near 2 gigs, then maybe I leave it at 2, maybe I bump it up to 4. You know, you've probably seen crazy sizes as well.
I have sometimes just to set things off. And if I have the disk space, I might set them all to 5 gigs. And then I wait to see what my growth is like. So it all depends. Sometimes I'd rather have a little more size than have growth events happen. So I plan accordingly. But like I said earlier, Erin, I want to make sure they all grow the same. So if you're not on 2016, and you're below 2016, there's 2 trace flags that help with that. And you need to see if you have 1118 and 1117 enabled. These will help. It does some allocation changes in the background, but it also does, and I'm not gonna get into those, but it also does a growth event. Now this is set server wide, which means if any file grows that has multiple files, they all grow together, right? This is not just for TempDB, so keep that in mind. But that will make sure all of your files stay in check and you don't end up with one file bigger than the rest and introducing contention. Erin, does that answer those questions for you?
Yep, I got some more though. You ready?
Sure, right on.
TempDB is a hot topic.
Oh yeah.
So what do you think of setting TempDB data files to a fixed size with no growth potential and letting the log file grow?
So setting them all large enough to fill up the disk drive, is that what I'm hearing?
Setting them, I don't know if it's filling up, it's a fixed size. So let's say that we had a 100 gig drive. I'm just making up numbers. We set them each to 20. So we had 80 gigs, we had 4 files with 80 gigs and then 20 free and let the log file grow. So what are your thoughts on that?
So it depends. A lot of times I don't do that. I like to have my auto growth. I don't like to stunt anything where I'm in a disk space situation where I have no availability for growth, because that can cause a resume generating event if I bring a system down because I've run out of space. So I tend not to do that. However, there's a thing called thin provisioning we're going to talk about. In that case, if I want to take all the disk space allocated, I might grow them all out so I prevent that. We'll talk a little bit about that in a minute. That would be the only scenario I would do that with. I tend not to take up all my space if I can.
I kind of in the same boat as you, although I've seen folks do that. So I think it's maybe just kind of what you've seen in your environment and what's happened. Another question related to file sizes, is it possible to make those too large? Assuming they're all pre-grown, pre-sized.
So I don't know about having any issues with making them too large minus the cost of your storage. I haven't run into an issue where that's a problem. That doesn't mean that doesn't exist. But storage is cheap, quote unquote. So if it's not an issue for that, making it so there's not a growth event because you've set them large enough, I haven't had a problem, but that doesn't mean it doesn't exist.
Right. And then I want to switch just slightly on the storage itself. So 2 questions related to the storage where TempDB exists. First one is, if you've got SAN storage underneath, do you still put TempDB on its own drive, even if the drives are carved out?
Yes.
Okay. And I do that as well. Why do you do it?
Well, so one, I have OCD and I like things set up in a certain order. So that'll be my main reason. Secondly, it's not true with the more recent SANs, like if you're using Pure and stuff like that, where you've really got some robust storage underneath and the disks are just, you know, performance incredible. So sometimes that doesn't matter. But if you're on an older SAN and they've actually allocated the disks differently, you want to make sure TempDB is on the fastest disk and you have that set differently than you would your normal data files. Again, storage has changed over the years. I hear the argument both ways of not doing it if you have robust storage. But then again, I have OCD. I like my SQL servers or my files set a certain way, so I will do it every time.
And then what about the log file for TempDB? Same as your data files, or do you throw that somewhere else?
So my habit is put all of TempDB on the same disk, including my data and log files. It's just something I always do to kind of keep things organized. I know people have separated those out. I definitely would not put the TempDB log file with my other log files. Just because, again, I want to have the fastest possible, and I really don't want to share that storage with anything else but TempDB. That's just my opinion, and that's my habit.
Got it. Okay, I think that we are caught up.
Awesome. Okay, a couple more things. Remember I told you patching is important. There was actually some heavy contention in the metadata side in TempDB in prior versions. So you were having TempDB contention issues without even knowing it. Most people, unless you read the CUs and see what's fixed, you might not even occur to you that there is an issue. So if you are on 2016 CU8 and 2017 CU5, that is where this metadata contention fixes were put in place. So again, patching is important to performance, and that's one of the things that affected TempDB. Now, trace flags. I love trace flags. Did you know that if you use table variables and are not using trace flag 2453, that when you run an execution plan, if you understand what estimated versus actual rows are and how that pertains to the amount of resources that are given inside each node of your execution plan, it would actually, if you're using a table variable, it would assume a row of 1, a row count of 1 that was coming through, because there was no precompile. There was no way for SQL Server to know how many rows to expect. So your estimated rows were 1, which means it did not allocate memory for a larger number of rows. It did not make sure that you had the right parallelism, things like that that happened because it would expect a larger row count. It thinks it's going to be 1. So if you do 2453, it allows SQL Server to the optimizer to actually get a closer number of rows so it can actually get the proper allocation of its resources. So it's no longer looking for 1 row. So therefore, your memory grants are better, your spills to TempDB tend to go away for those. There's lots of different performance impacts for that. So definitely take a look at 2453. It's one of those that if you are using table variables that you should have in your system. Now, I have a complete session on this. This is my absolutely favorite slide. And I talk about this all the time. Performance is more than just changing little knobs inside SQL Server. Performance sometimes relies on other personalities and other departments to make changes for you on things inside their system that might not be optimal. For example, I used to work for a really large port in Virginia, and I had a admin on the network side that him and I worked phenomenal together. He didn't make any changes on the network without talking to me, and he knew SQL Server was different than maybe Exchange, and he knew there had to be a symbiotic relationship between his settings and my settings to make SQL Server perform accordingly. Fast forward to my next job, I go into an environment where I am having major IO issues. I'm having disk issues. I've identified some bottlenecks on the VM side as well as the storage side. And I had a very combative relationship with that admin. Nobody likes to have their babies called ugly. Nobody wants people to identify issues in their system that they may or may not be responsible for, or that they've implemented or thought that was a good idea. As a DBA, we tend to find these things sometimes, and we tend to point these out. Without a good relationship with your admins, things can really go sideways. I actually had, I don't know if you know who David Klee is, but I had so many issues that David Klee came to me and I asked him, hey, can you take a look at my system, talking with my boss, and got permission from my boss. Can you take a look at my system and kind of just peek in and tell me on the network, SAN, VMware side, where my bottlenecks are, because nobody believes me here. I need some proof. So he actually went over my shoulder, did some screenshots, and logged in and took a look at some things, wrote up a beautiful 15-page report. In that report, he actually pointed out every single thing that needed to be changed, and said at the bottom, this was done for Monica because she's a valued member of the community. I'm like, yay, I'm gonna get a promotion. This is awesome. We were able to take care of this and things are gonna get fixed. It'd be wonderful. Wrong. I turned in the report to the VP and he shared it with the network admin, and guess what happened? I got written up. I got a formal write-up because I went over his head, the admin's head, and pointed out that his baby was ugly in writing by one of the experts in the field. So this is my lesson learned, and this is why this is so important. When you come into a new environment, or you're starting to see that there are bottlenecks inside your system that are outside of the SQL Server realm, and you're gonna have to point out that somebody's baby might be ugly, this is what I do. I try to keep my admins drunk, fat, and happy. How do I do that? I tend to buy donuts for the network admin team. I tend to maybe take them out to a beer after work. Maybe I put a Christmas gift of a bottle of bourbon on the network admin's desk or something like that. Something, yes, they could be bribes. It could be a lot of things, but I'm about to call their baby ugly. So it's important for me, and it's important for the SQL Server's performance, that I'm able to work with my admins and get things done. I cannot have the adversarial relationship that I had with the past employer's network admin, and things inside SQL Server never get fixed, and then the environment doesn't work. It's important you have those relationships. So if you're having performance issues in your system, think outside of SQL Server. Remember, when you're about to talk about the SAN being slow or what needs to change, or you're about to ask questions that I've been pointing out as we go along in this, that they're a person and you're talking about their baby. When somebody comes at my SQL Server and says it's the DBA's fault, this is wrong, this is something that I did that shouldn't be done, I take it to heart because that is my baby. The SAN admin, the network admin has the same thing. So take it from me, keep them drunk, fat, and happy. Remember, you're gonna have to point out their baby could be ugly, and then things will actually get fixed. So if you take away from anything from this thing, this is definitely something you need to keep in mind. And remember, sometimes people call your babies ugly too, and you don't like it. So, be nice to your admins is my point. Speaking of that, let's talk about some of those ugly babies. Over-provisioned hosts can kill your SQL Server. Too many VMs on one host can kill your SQL Server. What happens on one VM affects other VMs. It affects your SQL Server. Over allocating and under allocating of CPUs affects your SQL Server. These are all ugly baby items that you need to be talking about. Now, how do you know these things are happening? As the DBA, if your environment is sitting virtually on a host, it is your job to ask nicely, after you've given them beer, pizza, donuts, whatever it takes, to see if you can have access, read-only access into whatever VM tool that they have for looking at administering their VMs. vSphere, for one, is one that you would use for VMware. Ask and see if you can have read-only. Keep an eye on where your VMs land. Are they moving them from one host to another? Are they allocating too much memory on that box? How many CPUs are allocated? I actually had a client whose systems were completely down. I don't know if you guys have heard of the patching, it was a while ago, Spectre and Meltdown. Well, what that does is, say you have a host that has 32 CPUs on it. Those 32 CPUs are allocated between VMs. And there's a thing called hyperthreading. Hyperthreading makes it so those 32 are actually 64 because it's hyperthreaded. Well, when you install patching, the Spectre and Meltdown, it takes away the hyperthreading. So I'm back down to 32. Does that make sense to everybody? Hopefully it does. I can't see your head shaking. Anyhow, what happened was they were completely down, and there was this thing called ready time. And the ready time was through the roof on the actual host when I'm watching the actual performance metrics. And inside SQL Server, I was seeing this thing called SOS scheduler yield. It's a wait type. And that means it's waiting for threads. It's waiting for the amount of threads it needs in order to put a transaction through. So it was not able to get the available CPU, the available threads to run the transaction. And it was just yielding and yielding and yielding. That told me that there was a problem on the CPU side. So I actually had to find out that they were being hosted by a company who installed the patches and who had allocated on this box that only had 32 cores, allocated 107 CPUs across their environment. That meant that my workload was not getting put through at all. I was already having performance issues prior to the patching, but now it has compounded, and I couldn't get my CPUs to my servers to respond at all because they were fighting over those CPU allocations. Things like this can really bring down a production system, and you don't know it unless you have eyes inside what's going on with your hosts. So please take a time to ask, read only. You're not looking over their shoulders, you're not double checking your stuff, you're getting insight to what's happening with your SQL Server. Now there's this thing called thin provisioning, and I'm sure it's happening to most of you, and it happens with storage. And this is what I was talking about when I was talking about TempDB and whether you want to take all the space on that drive. This is the only instance where I tell you yes. There's this thing called thin provisioning, and what it is when I go to my SAN admin and I say, hey, I want 500 gigs for TempDB. Can you give me a new drive? I'm about to install a new SQL Server and I'd like to do 500 gigs. And my SAN admin says, yes, thanks for the donuts this morning. I'll definitely give you that 500 gigs, no problem. We'll take care of that for you. And I'm like, yes. And I look at a T drive that he's just presented on my server and I'm like, yes, he has 500 gigs, but he's fooled me. What really happened is he thin provisioned the 500 gigs. It presents to me on the T drive as 500 gigs, but he really only gave me 100. And what happens when I hit that 100? It does a growth event and gives me another 100. And then when I hit the 200, it does a growth event and gives me the 300. Then when I finally hit the 500, I've actually gotten my full provision drive. Well, every time I have a growth event like that, that is overhead. That is a performance hit to SQL Server. That is a performance hit on the storage side that slows my things down. So what I want you to do when you ask for the drive next, you say, I want thick provisioned drives, which means he's fully giving you, he or she is fully giving you the 500 gigs. Now, if he comes back to me and says, Monica, you're crazy. You don't need the 500 gigs. It's going to take you years to get to the 500 gigs. You don't need it. I'm leaving it thin provisions because that's what we do. And it's really just a checkbox for them, thick versus thin provisioned. It doesn't take anything extra except for giving you the 500 gigs. So let's say he says, no, I'm not going to thick provision for you. You're not going to take all that space. You don't need it. What am I going to do? Aaron, this is when I go and set each one of those to 100 gigs and I steal all 500 gigs and make sure they're allocated to me, because I want to make sure I'm not getting the performance hit when those drives regrow for me and I'm able to actually take all my space then.
My good friend has a comment about that, which is if I can't work with you, I'll work around you.
That's exactly right. You know, I'm going to take that space. I'm going to take that space. And this is a common thing. You know, they're taught, which is a best practice for them, which I think is great for other things outside of SQL Server. SQL Server is different. Everything affects performance. I want the fastest throughput possible. I don't want to wait for a growth event. That's what I'm going to do. So, any other questions, Erin?
You're good.
All right.
Someone has had that happen to them. So it's probably more common than some of us even realize.
Exactly. Now this again, like I said, bring donuts in the morning, feed them, talk to them later in the day, ask them how those donuts were, and then talk about thin provisioning.
Yep.
Okay, compression. Compression is your friend. Compression not only makes the storage admin happy because you're using less space, but it also improves performance for you. Okay, so what I want you to do is look at your system, and I want you to use row or page compression on your indexes for sure when you're building those. It actually makes them faster. More data in memory happens when you can fit more data. Sorry, let me try that again. You can fit more data not on a page, but you can compress it so you're moving data from other pages onto that page. You're making it so you're able to get more data into memory. I hope that makes sense. Usually I'm drawing something out when we're talking about this, but compression makes things go faster. You've got less data, you've got more optimized data that you can bring in, and it'll go faster. So definitely take a look at that. There are store procedures you can run that will actually tell you what your performance gains can be when you estimate compression on your system. So I highly recommend looking those up. My friend Andy Mallon has a great blog post on that with a script that you can run to see what compression will save you. Now let's talk about backup compression. Backup compression is fantastic. I like backup compression because it actually makes my storage admin happy. I'm taking up less space with my backups. However, there is this thing called data deduplication. And you probably don't know this is happening on your SAN unless you've had the conversation with your admins. If you are using deduplication on your SAN admin will tell you you cannot use compression inside SQL Server. You cannot compress your backups because the SAN is actually taking care of the compression for you. It's doing deduplication and doing pointers. Now that's fantastic when it comes to saving space on the SAN. However, when you're doing a backup, the backup compresses is fine. But again, like I said, there's pointers. What happens when you have to restore that backup? You have to rehydrate that restore, and all of those pointers have to come back together. We actually had a client that took 3 days to restore on something that was deduped. And if they had a native regular compressed SQL backup, it would have actually restored in about 16 hours. Now, who can afford a 3-day downtime versus a 16-hour downtime? I can afford a 16-hour downtime. However, for that, there's a huge difference in time when it comes back to restores because the dedupe has to put the data back together. So something you need to talk about. Ask and find out if your SAN is deduped or not, and if you can use native backup compression and maybe store your backups not on that SAN, but maybe in the cloud or something else that will allow you to take advantage of that. Now, compression takes CPU speed, but it's worth it. It costs you CPU, but the amount of performance gain you get from that is golden. So, allow snapshot isolation.
Hang on. Quick question.
Absolutely.
This is an interesting one. Do you compress MSDB, master, report server, TempDB? I don't even know if you can compress that. SSISDB?
I tend to not touch my system databases when it comes to things like that. I don't know about you, Erin, but I usually keep pretty much hands off unless I'm doing some index tuning or something like that on those particular things. I tend not to do that. What about you?
Same thing. Like I would have quite honestly never thought to compress them. I usually don't see those databases grow that large. Right? The only one that I've ever seen grow significantly large is MSDB, and that's usually because of a problem related to service broker, which is a different problem to fix up and not something related to that I want to fix with compression. And then someone just threw in here, what about TempDB? Same. I don't even know. Can you compress TempDB? I don't think you can.
Yep.
No, because you'd have to compress objects, and you don't create persistent objects in TempDB.
Nope, exactly. Yeah, I usually don't do that.
Yep,
so I see where there's a question about it grows from time to time and can take over the drive. That's a bigger problem. You need to attend my Mastering TempDB TempDB session, and we'll talk about that.
Right.
But yeah, I leave the system databases alone. Like I said, I may index tune some of them on some edge case things, but leave them alone.
And Mala had a comment that MSDB can grow with job history. Agreed,
Yes.
but I wouldn't compress that, right?
Nope.
I'd purge it.
Yep, absolutely. You definitely need to maintain that and properly set it. Don't deal with compression on that.
Yep.
Any other questions?
No, you're good.
Awesome. Cool. All right. So I want to talk about this magic button. And to me, it's a magic button. It's so much of a magic button that it's default isolation level in Azure SQL DB. It's RCSI. It's allow snapshot isolation and read committed snapshot isolation. How many of you guys have dealt with blocking? You know, readers block writers and writers block readers. It's one of the biggest problems that you have inside SQL Server, and that's by design. You know, you want to make sure nobody's touching the record that you're reading from, making changes, and you end up with dirty reads or bad data, things like that. But blocking can bring a system down. How do you combat that? In this case, this is a magic button to me. It's something that everybody should consider. There's a thing called race conditions, which is an edge case to me that I haven't run into, that you probably should do some research on. We're not going to go into that, but it's something you need to look at. What this does is readers can't block writers and writers can't block readers because it starts to use a version store inside TempDB. And it uses the version store to allow you to read data before the next write comes through or the next change that comes through. It creates this version store and it manages it really well. It makes it so you're not really reading dirty data or anything, but it's preventing the blocking and it manages it. Now, remember I said it uses TempDB. So before you actually turn this on, it's critical that you go back to my slide number 3 or whatever it is and check off those boxes and make sure your TempDB is set up correctly. This will cause the size to increase because again, it's using a version store inside TempDB. So inside the properties on a database level, you can set read committed snapshot isolation and allow snapshot isolation for those databases only. Now to turn it on, you need to be in single user mode so it is a downtime event because it creates a lock for it to make that change. So keep that in mind. But I had a client that had such bad blocking because they were actually doing selects off of a production database for reporting. And anytime anybody ran a long report, none of the updates or inserts could happen and they were having major blocking and lots of complaints. I told them about this option. We chose a window that they would make this change. And I said, don't tell me when you actually implement this. I'll tell you the next morning when you do. They were using Century 1, so I was able to go back in time and look at performance and see the exact time frame that they turned this in because all their blocking disappeared. It just all went away because now TempDB version stores and everything is handling the commitment or the reads differently. So my friend Kendra Little has a really great blog post that you can look up, RCSI Kendra Little, and she gives you this grid that tells you about these two options, allow snapshot isolation and read committed snapshot isolation. You can turn both of these options on, or you can turn one or the other, depending on your circumstance. So I want you to go and look for that prior to turn this on and get a little bit of better understanding of what exactly I'm talking about here. But in general, I want you to just note that if you're having blocking issues, read committed RCSI, read committed snapshot isolation is something you definitely want to take a look at. It can be a big saver for you and change your complete environment.
So Monica, can you talk about the difference between using RCSI versus using the wonderful no lock hint? I inserted the word wonderful. This is a true question.
The difference is you should use RCSI and you should not use no lock. That's what it is, plain and simple. So no lock, and we could spend an entire hour, I know I'm getting close on time here and we're gonna go over. No lock can allow for dirty reads. Let me do a little explanation on that. Say you have a bank account. The bank account actually runs with the store procedure that presents the amount in your account, that value. Inside that code, there's no lock. If I'm looking at my account, it says I have $1,000 in it. I hit refresh and all of a sudden it says I have 9 cents. I hit refresh again and it says 954. I hit refresh again and it says $1,400. Am I going to trust what's in there? No, I'm not. That's what's called a dirty read. No lock allows you to read dirty data. Did you hear that? It allows you to read dirty data. I want to know what's in my bank account when I actually hit refresh and know that value is correct. Okay, so no lock, in my opinion, should never be in your system. That is a very high level explanation of what it actually does to the system. No lock tends to be put in code by developers because they think they're doing something good and trying to avoid blocking and trying to actually put code in that has zero adverse effects on returning data, but it does. It does. So since we're running low on time, we could go into this for a really long time, but just know, don't use no lock. Definitely take a look at RCSI. If you have no lock in your system now, you may want to take a look on taking all of that out before implementing RCSI. Definitely test your system. Know what you're doing before you do it, but say no to no lock.
Okay, there's a couple other questions that I'm just going to answer so you can keep moving, but you've got, up to like 30 minutes if you really need it. So
okay,
you're good.
We're good. Awesome, because we're only halfway through. Didn't I said this can go?
Yeah, you did.
So 90 minutes. Okay, all right, Erin, I'm going to leave those questions to you. We're going to move on to the next one.
Cool.
And we'll go from there. So statistics. It's the magic sauce that helps the optimizer. It is what tells the optimizer how many rows to expect in general terms inside your execution plans. Keep in mind your estimated versus actual rows. You want those estimated rows to be as close as possible to the actual, so SQL Server and the optimizer knows what resources to allocate to make sure it has a large enough pipeline, so to speak, to move from one transaction type or one node to another within inside that execution plan. So you want to make sure these numbers are as accurate as possible. That's where statistics come in. Now, you want to keep these up to date. When you're doing your index maintenance, are you including, update statistics as part of that? Are you rebuilding your indexes, which are keeping those statistics updated? Are you using OLA's script? And in OLA's scripts that says update statistics equal to yes, you want to make sure that flag is there so your statistics are being done. If your data is changing rapidly all of the time, maybe you need to be updating your statistics more than weekly as part of your index tuning. Maybe you need to be updating statistics on their own nightly. The amount of data change that happens makes a difference in whether your statistics are good or not for the optimizer. So please keep these up to date. Also, there's an option inside your database where you can actually change your auto statistics. Everybody has auto statistics set, which means when a certain threshold is hit for change, your statistics gets updated. Well, there is a performance hit when that happens. There's a pause that occurs in the background that stops any selects or updates or inserts happening while that statistics updates. It's a blink of an eye, but there is a pause. If you change from synchronous updates to asynchronous updates, then you don't get that pause. Your system will allow it to use the current statistics, wait until there's an availability for an update to that statistic, and then update it. So that's something you may want to take a look at, which would be switching from synchronous to asynchronous on a database level. Large tables. How many of you guys have tables that are millions and millions of rows? If you heard what I said a few minutes ago, it was your statistics auto update when a certain threshold of change occurs. So if you have, let's say 20% is the threshold, you have 1 million rows, you have to wait for 20,000 rows, whatever the 20% is, I'm not good at math, to change before it gets an auto statistic update. That can mean if you have billions of rows or trillions of rows on a table, you are waiting a really long time for that statistic to auto update. With trace flag 2371, which is now defaulted in 2016, pay attention to anything that I say that's now defaulted, because that means it's important, right? There's a reason why we're defaulting these. If you are prior to 2016, then you need to enable trace flag 2371. And what that does is it changes the scale of how many rows, what the percentage is of data change required before that auto statistics happens. So if, let's say, if I have a 10 million row table, maybe I only need to change 100,000 rows before my statistic triggers. Maybe it only needs to change 10,000 rows before that statistic triggers. So I definitely want you to take a look at that. If you had tables larger than 1 million rows, let's say, and you're not using 2371, definitely take a look at putting in this trace flag so you can change that algorithm of when that auto statistics will happen. And then you developers out there, do you know you can make your own statistics? If you know there is a field that you commonly use or a combination of fields that you commonly use, and it's important to know those row counts, estimated versus actual as close as possible, maybe you can have some forethought to create your own statistics. You right click, create statistic. It's very easy. And you can actually make your own. So something to keep in mind, statistics is critical. Keeping those maintained and creating your own where needed can really make a huge difference on performance, especially within your execution plans and the allocation of resources that happen in the background. Wow, we're really behind. Okay, so this is good. So max DOP, everybody's heard about max DOP, and hopefully, and its partner I call cost threshold for parallelism. So what we need to talk about is setting max DOP on a server level. What that says is, in partnering with cost for threshold parallelism, it says your thing needs to cost a certain amount in order to go parallel, meaning it's going to use multiple threads. On a default, it's set, cost is set to 5 and max DOP is set to 0. That means a cost of 5% or 5 is going to trigger it to go parallel. What you want these to be set as, and this is generalized because it depends all the time. I'm talking from in general, what's my defaults, what's my go-to, is if you're gonna set a max DOP of 1 per logical core up to 8. So if I'm running 8 cores, you're gonna set max DOP at 8, or if you wanna be cautious, you're gonna set max DOP at half. So it only uses 4 threads, for instance, rather than the 8. Does that make sense? I'm usually drawing this out. So it's kind of hard to explain without, and I'm not on camera, so you can't see my hands, which I'm sitting here using trying to explain this. So why do you want to do 8 or lower? There is a rate of return where if you have too many cores and your max DOP is set too high, that you can actually cause larger overhead, and it can cause a higher CPU usage, and you can actually have issues. So what I want you to do is look and see what your max DOP is set to. If it's set to 0, I need you to look to see how many cores you have on your system. Maybe you start with half, and if you have 8, maybe you start with 4, and you see how things work. You can go up to 8. Now there's this thing called NUMA, and that gets everything complicated depending on how you have your cores set up. So there are bits and pieces to this if you're using NUMA that you need to look at differently, but I'm talking very general terms here. Max DOP, if you want to start out cautiously, would be half of the available cores that you're in, up to 8. Now caution when you change this, it will flush your cache. So this is something you do not want to do midday, and you want to keep that in mind. Now the cost, I like to actually set a good start at 35 to 50. That means I've got to get a cost of 35 to 50 in order for my execution plan to go parallel, meaning it's going to use more threads and then come back together. There's this thing called CX packet weights. What CX packet weights has to do with this parallelism that happens. When a transaction spreads apart into multiple threads, those threads have to come back together in order to move on to what I call the next node inside an execution plan. Those are CX packet weights. It's bringing those threads back together to move on. If you're seeing tons of CX packet weights, it may be an indication that your cost might be too low. Maybe you need to bump your cost up a little bit more so it doesn't go parallel. It may read better going serial. So there's a lot we can talk about with both of these, and given the time, I'm not going to go tons into it, but just know these two work in tandem. You want to be able to control how much parallelism happens in your system, how many threads it uses each time it goes parallel, so you don't end up having CPU issues. And remember, don't over allocate the max DOP. If you have 34 cores, switching your max DOP to 34 or even half of that, what is that, 16 cores, or 32 and 16, 16 cores may be too much. You may be creating too much. So 8 seems to be a magic number inside SQL Server. I would definitely try to keep it at 8 or below, but know your system and definitely take a look that they are not sitting at 0 and 5. Okay, instant file initialization. Again, we're thinking outside of SQL Server. We're looking at the box that we're on. What instant file initialization is, IFI. For example, let's talk about when you are creating a database. When I create a database, it needs to go out onto the disk because it's going to be created on a disk drive. It's going to go out there and it's going to write zeros. And so say it's 500, I want to create a database with 50 gigs. Let's take 50 megs. And then I create the database and it actually has to parse out zeros on the disk before it actually starts to write and create my database. What we want is, and that's actually taking time to do that. What we want is it to instantly create my database. We don't want it to write the zeros on the drive before we get our database created. So in order to do that, we have to grant SQL Server's the service account just a local policy security right that says perform volume maintenance. So you go into your local security policy, you look for perform volume maintenance task, and you simply add the SQL Server service account. And what this does is it allows it to skip creating the zeros before it actually creates my file. So let's look at this. We can see this happens for restores. It's actually for growth events. If my database were to grow, it needs to write the zeros out before it actually allows me to get my database back with that growth. So those are just examples of what it will do. Look at this. So if I created a 5 gig database without instant file initialization, it takes me 1800 milliseconds for it to write those zeros out and actually create and present my database. With file initialization on there, IFI, it takes less than half, a third of the time for it to actually create the file for me. Now imagine if this was TempDB and it's 100 gigs and it gets created upon restart and I have to wait for that database to grow and get created upon restart. My restart could take quite a while, but if I had IFI, that instantly creates that 100 gig TempDB file for me without creating the zeros, and I'm booming and my server started faster than what I had prior. So definitely something to look at. It's very, very simple. It's a permission on the box, the Windows box. So take a look. Okay, we're gonna talk about virtual log files pretty quickly here because where are we at on time? Okay, we're moving along here. Virtual log files. Think of a log file as a round robin that has buckets. Very, very simple, has buckets. As your files grow, your log files grows, more buckets get added to it based on the growth event. And it's a certain amount of virtual log, let's say buckets, that get added every time a growth event happens, depending on the size of the growth. Now this can get really, really large. If you are not looking and seeing what your log file, your virtual log file counts are, you could be having a performance issue. Ideally, you want your virtual log files to be less than 100 for all logs that you have out there. So what I want you guys to go back and do, I want you to run a script. You can look on my website. I have a VLF script out there that you can grab, and it'll go through for each one of your databases and tell you how many VLFs you have. I've run into systems where TempDB is supposed to have 100, and it actually had 72,000 VLFs. Now, when a transaction is trying to find a place within inside your log file of where to, quote unquote, put its data, and what bucket to use, imagine it having to go through 72,000 segments before it found the proper bucket in order for it to use it. So in general terms, think of this as your log file in buckets. It's trying to find what the next available place is to write to. And if it's going through an exorbitant amount of buckets, you're creating a performance hit. How do you actually get your VLFs down? You're going to end up shrinking your files, resizing them, and then definitely maintaining the proper auto growth amount. If you are auto growing at the 1 meg default, or whatever that used to be, 1 meg, and you're getting tons and tons of growth events, that means you're getting tons and tons of VLFs, which means you're slowing things down. So I want you guys to go and run a script against all of your log files, find out what your VLF counts are, make sure you're maintaining those under 100, which is a shrink event on the log file to get them back and regrowing those and maintaining the proper auto growth amount. Okay, I could go into this for a long time, but again, we're running out of time. So I'm going to move on from here. Indexes. So many people create indexes and you set it, forget it, right? They create them, they don't touch them again. Every index can be wasted rights and wasted rights and IO. I want you to make sure when you're creating indexes that you're also doing maintenance on them outside of your rebuilds and reorgs. You're looking at them to see, are your indexes being used? Do you have duplicate indexes? Are you having the correct covering indexes out there? Things like that. Can you consolidate your indexes? I'm hoping that you're at least doing this quarterly. You can run scripts, pull out all of your indexes, throw them in Excel, and sort them. If you notice that you're seeing duplicate indexes, you are getting a ton more write overhead than you should be, because you're writing that data in multiple places when you really don't need it. Also, find your missing indexes. Are there missing indexes in your system that can actually help your performance? However, when you go to your execution plans and it says you have missing indexes, don't just right click and add that index. You could be creating duplicates. Take it a step further and look and see at what you currently have as your indexes. See if one of those can actually be edited instead of creating a new one. Maybe it can be altered and you just need to add a different included column. Do your due diligence. Don't just right click and create every missing index that you have. There's tons of stuff associated with that you should be thinking about. And I know Brent has a couple sessions on that. But I want you to think about indexes differently. Think of it not only for performance for reading, but what kind of write IO are you creating by this? Make sure you're maintaining and cleaning up those indexes, consolidating them, doing that quarterly, and make sure your maintenance is beyond just those rebuilds. Now, I know this is the last slide, so this is just going to be a quick and dirty. I want everybody to pay attention what's in that green square. There's a thing called a key lookup, and this will create death by 1,000 cuts. I have seen systems that have major performance issues, major IO issues, major memory issues, and it's all because of the code that's an index is not being exactly what they should be, because they are actually having these key lookups. What a key lookup is, it's actually going out here and saying, for instance, I have select A, B, and C, where C equals whatever. My index up here, such as order lines, is indexed on C. I'm getting a seek. It's fantastic, wonderful, but I'm still needing column A and B. So what's happening is this key lookup is doing another read out to the primary key, and it's going to find that A, B column that I still need in order to return all my results in the select. I hope everybody's following that. So to simply fix this, all we have to do is go to that index seek, alter that index, and add A, B, and C, A and C, I'm sorry, the two select columns, A and C, onto that index as an included column. What does that do? That actually means the key lookup goes away, the nested loop goes away, and I end up with a seek and a select. So for performance, imagine you have a store procedure that gets run every second that has 10 key lookups in there. The amount of round robins it's having to do to go out to that primary key to pull that additional field A and B is huge. The overhead on that can be massive. So if you go and you see any key lookups in your system, you can actually get rid of a lot of that overhead just by addressing these. And I've seen entire systems change dramatically just by cleaning up these key lookups. So you don't need to know a ton about store procedures, about execution plans. You don't need to know a ton about indexes. This simple little trick can do a big performance gain for you. On your indexes, like I said, look for these missing includes in the key columns. Look for scans in your execution plans. Is there a way you can reorder your index that gets rid of the scan? Is there a way that you can rewrite whatever code that is that gets rid of the scan? These are things to look at. Sorts. Sorts are one of the most expensive things inside your execution plan, inside your query. Why are you sorting? Why do you have a store procedure that has 5 sorts in it when all you care about is the final result being sorted? Every time you resort, that's overhead in your system. So I want you to go through and figure out why you're doing these sorts. Can the sort be taken out? Maybe the sorts are being done in a report, and the sorts are being done in a sort procedure for a report, and then the report is being sorted again 3 different times. So why are you wasting SQL Server's overhead in that sort? Look at these things. These are quick things that you can actually fix easily within your execution plans quickly without having to have a ton of knowledge. Get your sorts out of there if you don't need them. Again, the key lookups, spills to TempDB. Spills to TempDB have a lot to do with your statistics, your estimated versus actuals. If it doesn't give you enough in your quote unquote pipeline, it doesn't give you enough resources to do what it needs to do because your row counts are off, then it's going to spill to TempDB. It's going to spill to disk, which could give you a performance hit if your disk isn't great. And what you want to do is prevent those TempDBs, or prevent the spills to TempDB. How do you fix that? I'll give you one guess. Statistics, right? If SQL Server doesn't know to expect 1,000,000 rows and it only expects 100, do you think it's going to give you the right amount of resources? No, it's going to have to actually take you from memory and put you to disk to complete what it needs to do, which causes you a different overhead, right? Additional overhead. So these are quick, easy things, just 4 things I want you to look at inside an execution plan without a ton of knowledge that you need in order to fix these. These are going to be your heavy hitters, in my opinion, that you can quickly fix, especially those key lookups. If you hover over key lookup, it tells you what the output columns are. Those output columns are what you need to add as include columns inside that seek. And you'll be fine and dandy and everything will work well. All right, so I'm only 20 minutes over. Sorry
Hang
about
on.
that.
No, you're good. You're good. I think that we can take a couple minutes for a couple more questions, if you're cool with that. Okay.
Yep, I'm good.
So I want to hop back to indexes for 3 of these. Okay. So the first is, and this is a fun one. There are those who strongly suggest that doing index defragmentation regularly is a waste of time and resources, and you should not be doing this. At a high level, can you make a case why we need to keep doing index optimization?
Oh, that's a good one.
It is.
I am not of the mindset of not doing index optimization. I'm going to tell you 100% of the time, you need to be rebuilding and reordering them every time. You don't want fragmented indexes. You don't want the extra overhead. Index maintenance to me is huge. You need the performance and the most optimized environment as possible. I'm not going to go into, because of time constraints, that's going to be my answer.
Yeah, I'll echo that.
Yeah.
I'll echo that. I understand that storage is fast and people have lots of memory, et cetera, but there are scenarios where when you have a higher level of fragmentation, right, then the optimizer knows that there's more IO that has to occur. And so that can influence the cost of a plan. Yep. So that can cause a plan to be more expensive than it could be if the index was not fragmented or as fragmented.
Absolutely.
So I think in general, from our perspective, Monica, I would guess that a lot of times we run into folks who are not extremely savvy DBAs in terms of setting up really extensive different maintenance plans, right? Maintenance strategies, jobs, to make sure that not only is fragmentation addressed, but also statistics. And so some people rely on rebuilding those indexes to get those stats updated.
No, that's what I said. Sometimes you need to have separate statistics plans, separate statistics index maintenance. And some
Yep.
of my clients do it daily. I have one that has to update
Yep.
some hourly because their rate of change is so huge. And they can easily get a plan skewed or a bad plan that comes through. And then they end up with a downhill spiral. So knowing your environment, but statistics, like I said, is the magic sauce. Keep those in
Right.
order.
Right. Okay. 2 more quick ones. Can I decide to remove the index, which has its seek scan lookup showing 0 and updates a much higher number? So, right, in DMDB index physical stats, when you look at that DB, or when you look at that DMV, if you see an index in there with seek scans lookups at 0, but lots of updates, do you, Monica, remove that, or what's your strategy there?
Okay, so I have a script that shows me what indexes are being used and if there's scans, seeks, and lookups against it. Now, I tend to watch those over time, knowing that those statistics that are presented in that are reset upon restart of that service. So maybe it's been restarted a month ago and those are sitting at 0. Maybe my server hasn't been restarted for a year. Those numbers probably are a little more better than something that's had a restart in the recent times. But I do keep an eye on those. What I tend to do when I'm doing cleanup, I will look for unused indexes. Before I actually do anything with them, I'm going to script out that index and I'm going to disable it before I delete it because I never know if it's coming back, right? Also, I have to keep in mind that maybe that index is really, really important at budget time. And I need that index. And if I don't have that index, I'm going to have major performance issues during the month of April when is our budget season. And I didn't know that index needed to be there.